like Raphael said, my name is Jenny Steffens. I'm the Senior Data Scientist and the Team Lead over at Hy-Vee. Today, I'd like to talk to you about innovation. A little bit about Hy-Vee. If you haven't heard of us, we're an employee-owned supermarket chain, and we're predominantly in the Midwest. Our headquarters are in West Des Moines, and we have 285 retail stores and counting in 8 states, but we're looking to expand that. We bring in about $12 billion annually. We're also named one of America's top 3 grocery stores a few years in running. At Hy-Vee, we like to say that we move at the speed of retail. Retail is constantly evolving, and we need to really keep up to stay ahead. Grocery is very competitive. What does this mean? For one, we need to adapt quickly to shifts in consumer needs. We saw a few examples of these in the last couple of years, predominantly COVID-19. Very quickly, we went from having the majority of our customers in our stores to 0 of our customers in our stores. We had an e-commerce platform, but it was still kind of developing. So we had to all hands on deck, really try to develop it to meet the need. Also, economic recession. This led us to focus more on our value stores. We call them Dollar Freshes. They're kind of more like Dollar Generals, but meeting the consumer needs as we see them. Along with these shifts, we also want to expand our retail experience to put ourselves ahead of the competition. So we acquire a lot of subsidiaries. This includes restaurants, pharmacies, financial services, and we also have a lot of partnerships. Basin, which is like Spa and Beauty, Joe Fresh, Canadian Clothing, and DSW recently was our newest partnership. Now an intro to data science. So our data science team formed in 2017, which is still a pretty young team. Hy-Vee has been around for 90 years, so that's very, very little time. We have a diverse set of backgrounds, so we have mathematicians, statisticians, programmers, machine learning specialists, and then also just pure research scientists. We're involved with every pillar of the company. Hy-Vee is very large, so supply chain, pharmacy, merchandising, real estate, software development, the list really goes on. And because we're involved in so many pillars, our projects look very different project to project. We have some optimizations, forecasting, anomaly detection, customer segmentation. You think about it, we've probably done it. This comes with its own set of challenges. Primarily, as a young team, we had to set our foundations and standards. Unfortunately, we had to do this while we were also putting out project work. This led to a lot of different styles between our team members. Again, very diverse backgrounds. So a research scientist's method of going about a project, very different than a pure programmer. So because of this, when we had somebody working on a project, we wanted to bring somebody else in. It took a lot of time-intensive onboarding to get them up to speed. Because of that, usually it was easier just to do solo projects. We called them project silos. No collaboration. Not ideal, especially because you want to really utilize those diverse backgrounds. Second challenge, our innovation projects were very, very slow. So this was actually brought up today. 80 to 85% of all data science projects fail. It just happens. Failure was not our problem. We're okay with failure. The problem was that we were failing too slow. Usually, we didn't know a project was a failure until 6 months had passed. A lot of time and a lot of money. Selecting the best models and really tuning them is manual and tedious. It would span months, even years for some projects. Then, when we did have a successful project, usually by the time we were ready, a year and a half, even longer, the business had moved on. We lost relevance. Again, Hy-Vee changed very quickly. So, our solution was in 2020, we signed a contract with H2O and got driverless AI. This helped us in a few ways. One, if we had a data set, we could get viability for a project in just a single day. This way, when we failed, we can fail fast and focus instead on the right projects. Secondly, driverless searches tens of model classes and hundreds of hyperparameters configurations at once. This meant that when we did get a model, we were more confident that it was the best model we could come up with. Third, and my favorite as the team lead, is with H2O, we got personal tuning sessions that allowed our scientists to work alongside established experts and sharpen their skills. We were able to stand on the shoulders of giants. Now I bring you to a case study. So at Hy-Vee, we have something called shortcuts. Basically, this is kind of just like cut and packaged produce. It's aimed for people who cook at home, just to make their lives a little bit easier. So we actually prepare the majority of this in a singular distribution center, and then we ship it to our stores the next day. So very quick turnaround. Our task was to improve the movement forecasts. This included two things. One, we wanted to minimize the out of stocks, underproduction. We wanted to make sure that if there was the demand, we met it. Two, we also wanted to minimize our shrink, overproduction. So we didn't want a lot of our food to go to waste. Very thin line to tread. But we were able to do it. With driverless AI, we produced an improved model that added $2.6 million to Hy-Vee's annual revenue. That was one data scientist, 4 months, $2.6 million. Pretty good. So after a lot of trial and error, we came up with a project workflow that really ensured that we were as successful as we could be. A few stages I have here. First, exploration, 1 to 3 weeks. Second, viability. This is the new stage that H2O allowed us to have, just a couple of days. Then proof of concept, advanced tuning, and then finally deployment and integration. So exploration. This takes about 1 to 3 weeks, really depends on the project. First order of business is we need to meet with our stakeholders. These are the people in the business that are sponsoring the project. Very critical that at this point we're focusing on the business need as defined by them. So as problem solvers and as data scientists, what we like to do is we like to focus on the solution and the technicalities. We need to fight that urge. Just focus on defining the problem correctly. So this includes recording requirements, any priorities, any constraints, and specifically the underlying goal. So increasing customer spending, minimizing waste, whatever they want in their terms. Once we have that, then we take that to H2O. We have a meeting with them where we have a brainstorming session. This is where now we start translating the business need into a data science problem. Specifically, we want to determine how the ROI, return on investment, will be measured. And we also start connecting with our use case specific experts. So this can be people who have experience in the actual use case, like supply chain, or people who have experience with the model class, like time series forecasting. We also at this point do background research if we need to. So the new H2O phase, viability. This is just 1 to 2 days, very quick, but very important. I would say the most important. First, we collect an example data set and upload it to H2O. So this is data that we could access today. Hy-Vee has a lot of different parts of the company. Our data is very spread out. We just want the data that we can have in our hands today. Usually at this point, we're doing some sampling too. So for sales, this might be sales data for a specific store, just to kind of cut down on that data size. Once we have that data set, we create a driverless AI experiment with just default settings. And this will give us a taste of the accuracy out of the box. With this, we can come up with a timeline for how long we think it'll take to improve it. With this in hand, we can report that back to our stakeholders. So at this time, we have all the information we need for a project proposal. 2 things will happen here. Either project moves on, or it gets shelved. Both are okay. Stage 3, proof of concept. This is 2 to 4 weeks. So at this point, we want to start reaching into every data set we can think of and grab any possible raw features that we can think of. So I did say raw. At this point, we're not doing any feature engineering. This is because we don't have to. There's no manual feature engineering here. Data goes straight from SQL into H2O. So driverless will automatically engineer additional features based on what we upload. So we're going to rely on that at this stage. Also, we don't have to do any manual feature selection. So usually, it's not the best practice to just grab whatever you can think of and just throw it in. With driverless, though, you can. Driverless will automatically drop any features that are relevant, so we don't have to worry about it. We throw the kitchen sink. Once we have that data, we upload it to driverless. We tweak expert settings a little bit, and create some leaderboards. This allows us to look at different model types at once and really select a winner. We also look at strengths and weaknesses of the models depending on use case. You might want different kinds of accuracy. You might favor over-prediction, under-prediction, what have you. But at this point, now we have a winner. We present this model to stakeholders and get their feedback, anything that they would like to see changed. At this point, the model is ready to start making some predictions. So usually, we'll start sending out predictions and start getting feedback there. So 4 is advanced tuning. This is 1 to 3 weeks. Really, you could do this forever, but we tend to stick to 1 to 3 weeks. First order of business here, we're going to be scheduling tuning sessions, about 1 to 2 hours each, with H2O's modeling experts. These are the use case specific experts from earlier. We're going to walk through our current experiments. We're going to get advice on strategies for improving accuracy. And we're also going to have our team members be trained on the specific model type. And we'll get some resources on further training that we can do on our own time. Second, we're going to really look into our visualizations that are auto-generated for us to both refine our current features, look for some problems, and also to extract some insights for our stakeholders. These insights can look like a lot of different things depending on the project. They might be feature importances, trends we see in the data, prediction drivers, what have you. Either we can give these to the stakeholders directly, or we can pass these off to our analytics team. Hey, we found something weird. Could you look into it? Last stage here is deployment and integration. So driverless allowed us to really streamline the previous parts of our project cycle, but this really remained a bottleneck for us. It was time intensive, and it also required a level of programming and software engineering expertise that was just uncommon within the team. You already have to know so much to be a data scientist. Also, being a Linux programmer, that's a lot to ask for. It also did not scale. So again, we're deploying these by hand at this point. Each project that we deployed had to be monitored and maintained indefinitely. So very quickly, our team became overwhelmed with just 3, 4, 5 projects. Because it was so challenging to debug model failures, it meant that when our models did go down, sometimes they stayed down for days, weeks. This is bad news when we're trying to integrate ourselves into the business, because this means that we were unreliable. If we're unreliable, we're not going to get a lot of production systems relying on our predictions. So this year, we purchased H2O AI Cloud to help with our final stage. So when we were doing this manually, our time from we have the model to full deployment was anywhere from 3 to 6 months or more. With H2O Cloud, we're estimating this will only be 1 to 3 weeks. Vast improvement. Not only that, but now all our models we centralize in one location, so they're easy to look after, and monitoring is automatic. So we don't have to worry about outages as much. Also, everything is written in the same language. So once you learn how to debug something, you can debug them all. This allows our team to focus on being data scientists, not DevOps engineers. I have some final thoughts for you here. 1, a data science team is only as successful as the tools provided to them allow them to be. You can have the smartest people come up with the best models, but if you don't have the right tools, it's not going to get used. 2, the quicker a project can develop a proof of concept, the more likely it is to survive and provide that ROI that it promised. The more likely business is to invest in your future projects. And 3, those that cannot innovate at the speed of retail will be left behind. I went through that pretty quickly, but that's all I have. Thank you very much.